welcome back. Last time we were talking about factoring. If you missed that video, check it out in the link below. Today we're going to be talking about something similar. You may remember from your high school algebra class the quadratic formula. Okay, so it was probably an alphabet soup of numbers to many of you, and you had no idea where it came from. Well, that's what I'm going to address today. Where does the quadratic formula come from? It comes from completing the square. All right, so to set this up, let's say we have x squared plus 6x plus 4 is equal to 0. Okay, so remember from the last video we used the table method. Factors of 4 whose sum is equal to 6. So what do we have? 1 times 4 and 2 times 2 and, well, in this case 4 times 1 is the same thing. 1 plus 4 is 5, 2 plus 2 is 4, 4 plus 1 is 5. Uh-oh, we need a 6. We're not getting it. So we're kind of stuck because this method is limited to integers, to whole numbers. This is where the idea of completing the square comes in. So let's set up a general problem. Ax squared plus bx plus c is equal to 0, where each letter A, B, C represents a number. Okay, so what are we going to do? Let's divide each term by A. Okay, that's going to cancel. I'm left with x squared plus b over a times x plus c over a. Well, 0 divided by a is still 0. Okay, so, all right, as a quick side note, x plus b over 2a squared. All right, from FOIL, well, it's the same as x plus b over 2a times x plus b over 2a. Now we can FOIL first 2, outer 2, inner 2, last 2. X times x is x squared plus b over 2a times x plus another b over 2a times x. And then b over 2a squared is going to be b squared over 4a squared. Okay, I can combine like terms. That's going to be x squared plus, well, let's b over 2a plus b over 2a. 1/2 plus 1/2 is 1. So I'm going to have b over a x. And I'm going to have b squared minus 4a squared. All right, so this is perfect. What am I looking for? Well, notice the similarity between this portion and this portion. So to get that, I'm going to have to say x squared plus b over a x. That's the part I want here. But to get that, I'm going to have to subtract a b over 4a squared. So I'm going to have, well, on the left-hand side, I still have x plus b over 2a squared. Subtract this, b squared over 4a squared. Okay, so I can now replace this with that. All right, so x plus b over 2a squared minus b squared over 4a squared plus c over a equals 0. Now, I'm trying to solve for x, so let me move everything else that I can over to the right-hand side. X plus b over 2a squared. That's equal to b squared over 4a squared minus c over a. Well, b squared over 4a squared, c over a. To add or subtract fractions, I need a common denominator. So I'm going to have to multiply both the top and bottom by a 4a to get 4a squared. So it's going to be 4ac over a squared. I now have a common denominator. So that's equal to b squared minus 4ac divided by 4a squared. Now to undo a square root, or to undo a square term, I take the square root of both sides. So that's going to cancel that. Now if I take the square root of this, that's the same thing as taking the square root of the top and bottom separately. Okay, and that's the same as b squared minus. The square root of 4a squared is going to be 2a. Okay, so now I have what? The square root of this squared is going to be x plus b over 2a is equal to what? All this. B squared minus 4ac over 2a. All right, we almost have x isolated. We just have to get rid of this term by what? Subtracting from both sides. So x is equal to negative b over 2a plus, well, b squared minus 4ac over 2a. Now, a square root can have both a positive and negative value. Negative 3 times negative 3 is equal to positive 9. Positive 3 times positive 3 is equal to positive 9. So, we have a plus or minus, and we are left with x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. All right, wonderful. Now, let's see if I can connect it back to this example here. You're taking notes. You might need to pause the video before I erase this, so I have more room to write. I am going to plug in. All right, so in this case, x squared plus 6x plus 4. A is equal to 1, b is equal to 6, and c is equal to 4. And now it's just a matter of plugging it in. So x is equal to negative b, so negative 6 plus or minus 6 squared minus 4. A is 1, c is 4, all over 2a. Okay, negative 6 plus or minus 6 squared is 36. 4 times 1 is 4. 4 times 4 is 16. Over 2 times 1 is 2. Okay, negative 6 plus or minus 36 minus 16 is 20 over 2. Well, 20 can be rewritten as 4 times 5. Okay, so the square root of 4 times 5 can be rewritten as the square root of 4 times the square root of 5. Alright, the square root of 4 can be rewritten as 2. I can divide each term by 2 to get negative 3 plus or minus square root of 5. Okay, so if we write that as factors x plus -3 plus square root of 5 times x minus -√3 minus square root of 5, okay? Be careful with your positive and negative signs here. Just to simplify this a bit, it's going to be, what, x plus, well, you know what? I'm going to do it this way. We're going to FOIL this. First, outer, inner, last. So I'm going to have x squared plus, okay, I'm going to have all this multiplied by x. -3 plus square root of 5 plus -3 minus square root of 5. That's all times x. And then I'm going to have, well, -3 plus square root of 5 times -3 minus the square root of 5. Okay, so positive root 5, negative root 5, they're going to cancel. X squared. -3 plus a -3 is going to be a oh, you know what I did? Told you to be careful about those negatives. So that's actually going to be what? Minus negative, so that's going to be a positive 6x. Okay. And then what is that going to? No, negative times a negative is a positive, so we should be good there. But now we have to FOIL out this term. So what is that? -3. Okay, -3 times -3. That's going to be 9. Okay, I'm going to have, see, I'm going to have a negative, and a negative is a positive. Positive and negative is a negative. So 9 plus 3 root 5 minus 3 root 5. These are going to cancel. And then root 5 times root 5 is simply 5. 9 minus 5 is 4. So you can see how I got this. Okay? Before I was restricting myself to integers with the table method. And now I have, what? An irrational number added to a -3. That was not taken into account in the table. That's the power of the quadratic formula. -b plus or minus b squared minus 4ac all over 2a. So this works. This works all the time. Factoring has its limitations, especially if you're restricting yourself to whole numbers, which is usually the only practical way. Anyway, so in summary, where do we come up with this? Well, from completing the square. And you can see in an example where factoring failed and where the quadratic formula, as a result of completing the square, came to the rescue and gave us our answer. Anyway, I hope you enjoyed the video. Please like, subscribe, comment below, and I'll see you next time. Thank you.